Find the Maclaurin series for f of x using the definition of Maclaurin series. Assume that f has a power series expansion. Also find the radius of convergence. To get started, we have f of x equals e to the power minus 5x. And we could bring the Maclaurin series representation, as you could see right here. F of x equals a summation from n equals 0 to infinity. F n 0 at 0. That's the derivatives over n factorial times x to the power n. That's how we could write it with the Maclaurin series as an expansion of power series. To get started, we also need the derivatives, so we could write the summation. The second column in the table represents the derivatives. When n equals 0, that means it's the function itself. So we have the following: e to the power minus 5x. When n equals 1 means it's the first derivative. We have the derivative of e to the minus 5x will be minus 5 e to the power minus 5x. Finding the derivative of that will give me the second derivative, and that will give me 25, positive 25, because negative 5 is going to go down, times negative 5 up front will make it positive 25 e to the power minus 5x. Finding the derivative again, that will give me minus 125 e to the minus 5x. Again, one more time, that will give me a positive 625 e to the power minus 5x. Now notice that the third column is the derivatives when x equals 0. So when x equals 0, we're going to plug in 0 in every single one here and fill the table on the right side. But anything raised to the power 0 is 1. Anything raised to the power 0 is 1, which means the last column will end up e to the power 0, that's a 1, negative 5 times e to the power 0 again, which is negative 5 times 1, that's negative 5. This will end up 25. This will end up negative 125 times 1, and 625, and so on. Notice that this part right here that we're looking at on top is right here, and clearly it's powers of 5 but alternating. So to write the function f of x, which is e to the power minus 5x, we could write it this way: equals to summation n equals 0 to infinity of the following over n factorial times x to the power n, and the numerator represents the last column in the table, which is powers of 5, but we need it to alternate, so we're going to write negative 5 to the power n. Let's test it. When n equals 0, I have negative 5 to the power 0, which is 1. That is true right here. And when n equals 1, I have negative 5 to the power 1, and that's negative 5. When n equals 2, negative 5 to the second is positive 25, and so on. So we have it correct. If you want to expand it and see the terms, we could rewrite this as follows: that equals to 1 minus 5 over 1 factorial x plus 25 over 2 factorial x to the second minus 125 over 3 factorial x to the third, and so on. To find the radius of convergence, we're going to use the ratio test, and here we go. So limit as n approaches infinity absolute value of a n plus 1 sub a n plus 1 over a sub n will equal to the limit of the following. N approaches infinity. A n plus 1 is, when you write it down, instead of n, you plug in n plus 1. So we have minus 5 to the power n plus 1 times, since we have the absolute value, we have absolute value of x to the power n plus 1 over n plus 1 factorial. That is my a sub n plus 1. Instead of dividing by a sub n, which is clearly written on top right here, that is a sub n. So by dividing by that, you could flip it and say multiply. So we're gonna flip it and write multiply. So times 1 over a sub n. And to write this as 1 over n factorial becomes on top. That's n factorial. And I have minus 5 at the bottom side to the power n. And also absolute value of x to the power n down. So this is what we have. Simplifying this, we end up with the following. This is n plus 1 times n factorial, which I have this cancels that, and I have same concept with the minus 5 to the power n plus 1 and the minus 5 down to the power n. I have one more on top. Same thing for the x, I have one more on top. So we could reduce our steps equals the limit as n approaches infinity of the following. Since we have the absolute value, we're not going to write negative 5 by itself, so we're going to write 5 times the absolute value of x, because we have one more x on top, and at the bottom side we showed that we have n plus 1. And as n approaches infinity, the denominator goes to infinity, so the fraction goes to 0. This equals to 0. X has nothing to deal with the limit. We could put it outside, but there is no need. Clearly, this is less than 1 for all x. So r equals infinity. That's the radius of convergence. To summarize this, we have the following. We ended up writing the function f of x as the summation n equals 0 to infinity of minus 5 to the power n over n factorial times x to the power n. And when we looked at the limit of a sub n plus 1 over a sub n absolute value as n approaches infinity, it came up to be equal to 0, which is less than 1. So we are right here. This is called the ratio test. With that in mind, we say it's absolutely convergent, so it is convergent. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.